So now let's look into the hierarchical clustering, a step-by-step process. A step-by-step process to execute your algorithm. So the step hierarchical clustering is another popular unsupervised machine learning algorithm used to group similar data points into clusters. Unlike k-means clustering, which partitions the dataset into a fixed number of clusters, hierarchical clustering builds a hierarchy of clusters in the form of a tree-like structure, also known as dendrogram. So it does not require specifying the number of clusters in advance. So here is a step-by-step explanation of hierarchical clustering. So step 1, initialization. So assign each data point to a separate cluster. Of course, it's agglomerative. So then calculate the distance or dissimilarity between each pair of data points. Then step 2, uh, there you have to decide whether you want to go for agglomeration or division. Okay, so for agglomerative hierarchical clustering, merge two closest clusters based on a distance metric, example Euclidean distance. Merge two closest clusters based on a distance metric. Obviously, if it is a minimum linkage, then go for the minimum distance. If it is some other average. Okay, so first the next step is to merge the closest two closest clusters based on a distance metric, then update the dissimilarity matrix by computing the distance between the newly merged cluster and the remaining clusters. Repeat the above steps until all data points belong to a single cluster. So if you do the same with the division or divisive step, for divisive step, you have to start with all data points in a single cluster and then recursively split the clusters into smaller subclusters until each data point belongs to a separate cluster. So then we will go for the third step, which is dendrogram construction. So the third step, as clusters are merged or split, either it's a merged one if it is agglomeration, if it is a division one from big cluster, a single cluster, it will be split into the clusters. So as a clusters are merged or split, dendrogram is constructed to visualize the hierarchy. The dendrogram shows the order of merging. Basically, what you see on the dendrogram basically is nothing but order of merging or splitting and the distances at which these operations occur. The y-axis of the dendrogram represents the dissimilarity or distance between the clusters. On y-axis, what you see are the dissimilarity or the distance between the axes, and we can see one example also. Okay, once the step 2 is done, now let's move on to the step 3, step 4. Step 2, step 3 are done. That's dendrogram construction. Now it's time to get into cutting the dendrogram. Cutting the dendrogram as clusters. So to obtain a specific number of clusters, A cut is made at a certain height or dissimilarity threshold on the dendrogram. The cut defines the clusters as distinct branches of the dendrogram. So next step, final result. So the clusters obtained from cutting the dendrogram represent the output of hierarchical clustering algorithm. So each data point is assigned to a cluster based on the cutoff point on the dendrogram. So hierarchical clustering has different linkage criteria to measure the dissimilarity between clusters, such as complete linkage, single linkage, average linkage, and Warts linkage that we have discussed earlier in our previous slides. So each criteria uses a different method to compute the distance between clusters. So hierarchical clustering is useful for identifying hierarchical relationships within the data and does not require specifying the number of clusters in advance. So it's commonly used in various fields including biology, social sciences, and data analysis. So now what we are going to do, we are going to create a cluster. We are going to do a clustering to a real data set. So let's see how the data set looks like first, then we will get into the action. So in the previous section, so hierarchical clustering was performed on a simple data set that I have created. But now what we are going to do is we are going to perform hierarchical clustering on a real world data that I acquired from GitHub. Okay, and this is the data set, and it's a protein data set. It's related to the protein. Which country is consuming a protein from what type of food, basically whether it's from red meat, white meat, eggs, milk, fish, cereals, starch, nuts. And Albania, these are our entities, and what you see is the features or attributes of the data set. And each cell consumes each cell conveys certain information. Each cell is measures certain variable on columns. Okay, so this is our overall data set. And using word method, obviously we are going to word method, and this is what the response, this is what the clustering that we can get it. Okay, so let's get into serious business now. Okay, so now a real world data set example. Obviously it's protein data set. Okay, so let me put 6. Yep, done. Now it's time to import or load data set. So to load data set, we require pandas. So import pandas as pd. Then let's load the data set. So df is equal to pandas dot read underscore csv, and let me go for protein data set. That's protein dot csv. Okay, so protein dot csv. So this is our data set. Let's do some self test just for sake of it, and just to explore the data set before we directly work on it. So for that, let me take up this one. Yep, I'm gonna print df. Yep, this is our data set, and you can see, okay, total we have the 24. Of course, I'm going to just go for this head. Just head is more than enough. Yep. So red meat, white meat, eggs, milks, fish, cereals, starch, nuts, and fruits and vegetables. Fruits and vegetables, and these are the countries. These are the countries that we have: Albania, Austria, Belgium, Bulgaria, and Czechoslovakia. Okay, so these are what we have, and now it's time to, if you want to explore more about the data set, you can see. So just if you want to have the columns, yep, and here is the list of columns for you. And if you want to see the df dot shape of it, and let me copy this, and let me take n dimensions. Obviously these are all attributes, and here it is. It's 25 10. You got the 25 rows and 10 columns, and this is a two-dimensional. Obviously pandas is two-dimensional, it's a rectangular data. That's okay. So the exploration about data set is done for some extent. Now let's move ahead, and let's let's do our work. So let me take the features. That's x2. These are my features, and df dot index or integer location iloc. So from this till 1 to 10. So that's what our data set, and let me cross check what I have taken. So print x2, and where is that? Okay, this is what the data set I have taken. I've just taken only red meat, white meat, egg, or only features, and I did not take the first column, country. Okay, this was left aside, and I have just filtered out these things that you can see. That's what I did. It has total this, and I have filtered only columns, and that you can see here. So 1 to 10, if I just say 0 to 10, so I would have gotten all. You see that I got country column also. I would have got, I got country column also, but I would remove this and I put it 1, and I won't get country column. I'll get only red meat till fruits and veggies. So that's what I have filtered out, indexed. That's what I filtered out, sliced out of my data set. Okay. So now let's fit it into our data set. But for that, uh, I need to call up a library. So either I can use this one and fit the data set, okay, or I can use the other way method, the scipy, whichever I want. uh, Out of that, anything can be used. So let me take up this directly, either scipy or this. Okay, so now let's call up again. I'm going to use a word method. So protein clusters is equal to linkage and x2, and method, I'm gonna go for the word metric is Euclidean. Okay, so then I need to have the label list. So label list is equal to list of df. Obviously I'm gonna take up only country column because this is what is my label list. This is what is my label list. If you want to see what is my label list, nothing. So print label list. Okay, method word requires the distance metric Euclidean. What, let me copy this. Euclid, okay, spelling mistake, sorry. Yeah, and this is what my label list. Okay, so this is what my label list. Now let's put it into the action. So let's plot it now. Plt.figure, fig size, I'm gonna give a tuple of 13 comma 12. Okay, now dendrogram, and inside that, okay, so what's my cluster object? It's a protein cluster. And next I'm gonna go for the orientation. So let me give orientation, a right orientation, and show leaf counts false, leaf font size is 16, and that's enough. Just say float plt.show, and the final nail in the coffin is just attach the labels, and final nail in the coffin is attach a new column to that, the clusters column, back to our data set. So df of let me see, yep, I just call it as a df. Let me just say data, and data, let me add a column to the data set. So f cluster, f cluster, f cluster. So what we have is prot cluster, and I want two clusters, and criterion is max cluster. And finally let's print it, data dot head, and execute it. That's it, and here is your data set. Okay, so here you can clearly see how the data has been clustered into this. The whole data, the protein consumption, has been clustered into two clusters. This is one cluster, and this is another cluster. And this is how we use a hierarchical clustering to to cluster the data set, and that's what you can find out here. And this is what the response we got, and clearly you can see that Finland, Norway, Denmark, Sweden, UK, Belgium, France, Ireland, Switzerland, Austria, Netherlands, West Germany, till this they all comes under one cluster, whereas Romania, Bulgaria, Yugoslavia, East Germany, Portugal, Spain, Hungary, Czechoslovakia, Poland, Albania, USSR, Greece, Italy, they comes under one, uh, basically one cluster. Okay, and that you can clearly see, and this is how it's useful for us. And even you can attach them back to your data set to that column. Okay, so this is what is hierarchical clustering.